to get set up and connect to a remote machine. The second video showed how to download Athena and test that the download was successful. This third video will take another step with the Athena tutorial. So to start with, I'm going to open a new Brave window, search Athena tutorial MHD. Click on the first link here, princetonuniversity.github.io. So this is June of 2022. Well, this could change, especially since really most of the development is in Athena++ now. And I think that this is all legacy. So in the last video, we downloaded it. Today, we're just going to jump into documentation, tutorial, and then we did the quick start previously. We're going to do the 1D hydro Sod Shocktube problem. And so let's open up a new terminal. Go into SSH, use this alias that we set up in the first video to get to our remote machine. So this is the bash, or just in general shell prompt. This is my username, the machine host name, which we can check using the Linux command host name. And then we have this tilde money sign. So the money sign is just kind of delimiter saying that we're typing here. And the tilde is our current working directory. So I'm going to change directory cd to Athena stuff. I typed tab to autocomplete. That helps avoid typos. And then we have Athena directory. And then inside of here, we're going to start by doing this make clean step to remove all the executables that we compiled in the previous step, as well as whatever was linked together. Then we're going to do /configure. So we're going to use, and there's a couple of config, there's configure as well as config.status. So I'm just going to type a U, which then means that there's only one file that tab will complete to, and that finishes it. Then we're going to type with -gas hydro, and let's first see what happens if there's a typo. Because I think that it's going to be problematic if there's a typo. Configure error expected with gas, MHD, or hydro. Yeah, so it didn't like that. So if you get a configure error, there's probably a typo. It's probably best to just simply copy paste from here. But in case someone is not able to copy paste or doesn't feel like it, let's include one more typo. Configure error, invalid problem file name. Okay. And so now, just to be safe, I'm going to do / and then I'm going to copy paste. So we have a money sign for our sort of command prompt here. For them, I guess it's this percentage sign. So we're just going to copy from the configure. Then we're going to do /. So this says in the current working directory, there's a configure thing that we want to execute, and we're going to include the options with gas equal to hydro and with problem equal to shock set 1D. Okay, and so that worked. And so again, this is a one-dimensional problem, but the spatial order is referring to the reconstruction scheme. So this is using a cubic. All right. And then the next step is to do make all. And we had a problem because, and there should be a way to fix this permanently, but I'm not really sure at the moment how. So this machine set to default, unfortunately, does not know what default is. And so, I mean, one way to fix this, I think, would be to go to makefile, and then in the make all command, so make all actually does make dirs and then make compile. So in compile, so yeah, each of these does the make, and then it does a compile in these different directories. And so I was just checking for, okay, so this, I guess, inherits from what we type in make. So I'm going to try, so make options, the capitalization matters, and make options, there's this machine which sets to default. Yeah, so every time configure is run, this file is regenerated. So even if we just set machine to Kraken here, it's gonna get regenerated. Yeah, all right, select using machine name in command line. Example, Ofer, make all machine equal to Ofer. So we're just gonna do make all machine equal to Kraken, even though our machine is not Kraken, because in this make options. So I mean, one thing we could do is we could do else if equal machine MPA else, and then in here we can do which CC to figure out the path to the C compiler, and say CC equal to, and then that's the path, and then LDR, which LDR, yeah, actually LDR is just some linking thing. I don't remember what it is exactly. And this opt is the basically optimization order. So we can actually look for how this LDR is used. Actually, it's not used in here, so that makes it a little confusing. It's probably used in the actual compilation though. And so yeah, I mean, this LDR, it looks like in general is just always given the same path as to the C compiler, so it's probably fine. And then we're not doing anything with FFTW right now. Oh, but so this is going to get regenerated. So this is still not really going to help us. But if we do make all machine, could probably just do machine equal to Kraken in general, but we'll do machine equal to MPA since we just entered that. And missing an end if. So in make options, interesting. So if equal to, else, if equal to, might be missing a parentheses here. CC LDR opt else, if equal to else. Yeah, I'm not sure what went wrong there. So I'll just remove that code that I inputted there. Maybe it doesn't like machine equal to Kraken there. Huh. Oh, so it's back to line 99 is complaining. Oh, so that just doesn't work at all. Okay, well, that's a bummer. Just gonna have to say machine equal to Kraken, do make all, and then it works. Now it's compiling everything. And so you could kind of understand what's going on by kind of looking. This is all output though, so I mean the better thing to do would be actual to follow, like make dependent on the different make files that are actually executing all these commands. But we're gonna gloss over that a little bit. CD into bin. So that again, so ls lists the directory contents. So this is again saying to execute some like local file rather than a global command. So I like to do / to be more explicit. And then, so ... is saying look at the directory one above us, like the parent directory. So every directory within our current directory is a child directory, and then parent directory is one level higher. So if I type pwd, this is the directory like hierarchy. So root is the parent of everything, and then we're inside of the root folder, we are in this like AFS folder. So if we do ls/, there's all this random stuff. We're inside of AFS. Inside of AFS, we're inside of the MPA directory, etc., all the way to bin. And inside of bin, there's Athena, so / Athena, and then up one level over to test, 1D hydro, I'm using tab complete, oops. And then ath input sod. Okay, interesting. Oh, I forgot the -i. So this -i option is saying basically whatever comes after is going to be the input file, where it reads some parameters from it. Okay, so it ran. If we type in ls, Then our structure is a little different because ours is not alphabetized, but doesn't matter. So we have all these Sod problems. And now if you have supermongo installed, which I guess is maybe pretty general, it is installed here, then we can follow along with this tutorial. But one thing I'm going to do after this is I'm going to show how to plot with matplotlib, which is a Python plotting package, which is probably a little bit more modern than supermongo. I think supermongo dates back to the beginning of Athena, which is 2000s, if not 90s, or maybe even earlier, I'm not sure. All right, so then one confusing thing here is that they probably shouldn't have this colon here, because that's actually the output. So like here, for example, we don't have the colon for the read lines thing. All right, limits xd, device x11. So yeah, this assumes that you have an x window set up, you have x forwarding set up, which is, so one more thing. So in our bash rc, which we use to, yeah, so I have a bunch of extra stuff here because I added it back in, but this alias ssh mpa command that we use to SSH or to connect to the remote machine, there's this -y option, which means to basically pass all the graphics along through the port. If you don't include that -y, then this will then you won't be able to have this X window. And then you also need Xports installed on your Mac, or I think Xming if you're on Windows. Okay, so anyway, we're all good. And so we have device X11 box, draws a little plotting box, points X. So this is, you know, the X coordinates, and then D is probably density. And so it draws that, and it looks similar to what they have here. So this is a 1D Shocktube problem. You start out with a sharp discontinuity from 1 down to maybe 0, maybe 0.2. And then as that sort of standing shock propagates, you end up with a couple of different waves. There's a backwards traveling rarefaction wave. There's a shock which is propagated. And then there is actually like a forward shock that's broken off of the initial shock. So then now there's like these three shocks / I guess not all of them are shocks, waves. Whereas initially there was just a single discontinuity. Or not discontinuity, but a single shock. Okay, so that's how to get this thing working with supermongo, and then apparently quit, gets out of it. Now let's do module list. So if you're on a cluster, then you're going to have some modules. So I have not much installed right now, just some like defaults. So if I do Python and Python 3, if I import matplotlib, I don't think this will work. Oh, maybe it will. Looks like it will, just taking a moment. All right, and then, yeah, there are a couple of things you can do. I guess we'll just use NumPy. So all these .tab files, I think, are just like CSVs. I'm actually not 100% sure this will work, but we'll find out. It helps when you know, kind of, if you're the one constructing a file, it's a little bit easier to work with. And so we're going to load this, save it as a data variable. That worked. So this is going to be a NumPy array, so we can do data.shape to look at it. Okay. And yeah, so from this thing, we know that X is the, I'm not sure if this was 1 or 0 indexed is the thing. So I'm going to SSH MPA, go to Athena stuff, go to Athena, and then we're in the bin directory. So I'm just going to open up using VI, look at this tab file that we've been reading from. And so this tells us a little bit of information. So we've got the very first thing here. I'm going to just make this window bigger so it doesn't spill over to an extra line. So the first thing is the zone. Okay, so this is 1 indexed here. This is 0 indexed. So I zone and then X. So this is the actual x coordinate values. So in Python, Python is also 0 indexed. So let's say x is data all values comma 1, and we'll say d is data all values comma 3, and we can check in the header. That's interesting. Okay, never mind. So they have d as 3. So this is actually one index. So they were using the I zones rather than the actual x values, which is why this goes 0 to whatever, 150 or, well, even farther it looks like. That's interesting. So that's rather different. I think that they set up limits though. No, they didn't. Okay, I don't know what's going on there exactly. Yeah, so I guess we'll try 0 and 2. All right, so 1, 2, 3, 4, 5, 6, 7. So they've got pressure, possibly volume. I'm not sure what V3 and V2 are. Oh, these are different velocities. So pressure, the Z velocity, which is 0 because this is 1D. Y velocity is 0 because this is 1D. X velocity, then the density, then the X coordinate values, and then the just zone numbers. Okay. So this X is actually just the name of the zone number. Well, this is, yeah. So supermongo, I guess, is 1 indexed. Python is 0 indexed. So we're gonna, I think the name is confusing that they called this X, but we'll just stick with it for now. All right, and then if we do plt.plot xd, oh, okay. Oh yeah, so by the way, if X forwarding is not working, you can import matplotlib as mpl, mpl.use ag. So this ag is a backend which is useful for non-GUI stuff. So if you don't have X forwarding set up, then you can use this backend, and then you won't run into different X forwarding errors. All right, and so let's try, and then import matplotlib.pyplot as plt, and that's going to take a moment because there's kind of a lot that goes on in that module of Python. It can be the downside of using a remote machine is it doesn't have things cached as much because, well, there's a lot of users. Okay, there we go. So plt.plot, we'll try this again, xd. All right, and then we'll just try plt. Well, if you don't have X forwarding set up, then that's not gonna, you won't be able to show it to yourself, but you can save it as, we'll just call it test.png. And then it's always good to plt.close. I wonder if there's a with option equivalent in matplotlib. I'm not aware of it. And then let's go into SCP. And then, so previously I made an outgoing files directory. You can do make-dir-p received files. You don't have to do this, but I think it makes things a little bit more organized. And then I have a bunch of stuff here already. I guess I won't delete it all, but SCP from MPA, and then again, I just kind of like copy my old command, comment it. I should probably do something a little bit fancier, but this works out okay at the very least. And so I have, so the structure of this is I have scp-r so that I can copy directories if I want to, username at machine host name dot, and like the complete machine name, then this colon, and then I need the path. So I'll quit out of Python, do pwd to get the current path. Oops. There we go. Command C because I'm on a Mac. Command V. You can also always do edit, copy, paste if, for example, your keyboard is not as nice. I sometimes use a Windows keyboard with my Mac, which can get annoying. All right. And then inside of bin, you have test.png. We're going to copy that to the current working directory. And now I can open up like my Finder window. I can go to received files. Can let's see. So that thing was called test. All right. I can double click, and that looks pretty similar to what they have there. I'm not really sure why this is kind of like scaled differently, but all good, I would say. Okay, so that's a little basic on how to plot with matplotlib, even if you don't have X forwarding set up. And then what I haven't shown in previous videos is just kind of, if you have, for example, a lot of bash sessions open, then you can exit and it looks kind of confusing. It looks like it didn't do anything. That's because it exited out of one of the previous bash windows. So you just need to keep on typing exit until you get all the way out. And yeah, hope this tutorial was helpful.